All right. Well, we are hopefully pretty good at graphing lines, especially ones in slope-intercept form. And today we're going to be talking about systems of linear equations, which is just more than one. All right, more than one. So now we have two linear equations. All right, and what we want to do is find the solution to the system. The solution to the system. The solution to the system is one point, one coordinate pair that makes both of these equations true. I don't even know if you remember on Khan when we did um, an exercise or an assignment that was checking to see what coordinates would make an equation true, right? And you had to plug in the x coordinate for x and the y coordinate for y and see if it made that equation true. All right. Well, we're trying to find one special point that makes both of these equations true. All right. What does that look like on a graph? That looks like where the lines cross, the point of intersection between these two lines. So we're going to be graphing two lines, but we're going to be trying to find one coordinate pair, one point that makes both true, and that's where they cross. So let's get going, okay? Let's get going by graphing both of these equations. I'm going to use different colors, so I'm going to use the first one's going to be blue, and the second one's going to be, I'll go with red. And anyway, so we plot our y-intercept. Our y-intercept is always that number there, so that's 2, because these are in slope-intercept form. All right, slope-intercept form is nice for graphing. Now I'm going to use my slope here of 1 over 2. That means rise 1, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. Okay, oops, not a very good point. Then I can do the backwards, down and left, down and left, down and left. It's important that you get all your points in there. Whoa, I messed up. There we go, down and left, down and left, down and left. Okay, now, important that you get all your points there because that'll give you a better shot of finding the point of intersection. All right, now we're on to our next one. I'm going to go to red, and I'm going to look at this second equation, and we got a y-intercept of 5, and then a slope of -1. We make it into a fraction, and it's a negative slope, so that means I'm going to go down first and right, down and right, down and right, down and right, down and right, okay? And I'm going to draw my line in. Okay, now can you see where they cross? I hope you can. All right, I've changed to purple, and they cross right there at that point, and that coordinate pair is, let's see, over 2, up 3. Over 2, up 3. All right, now we have that coordinate pair. That is what we call the solution to this system of equations. The point of intersection is the solution to the system. All right, say that a couple times. Seriously, like pause it and say, the point where they cross is the solution to the system. Solution to the system. Solution to the system. All right, maybe we should make a dance about it. Cross your arms and find that point and say solution to the system. Solution to the system. All right. Now, important that you understand what a solution to a system actually is. So what we're going to do is we're going to look at these two equations and see if that coordinate that we just wrote down as the solution to the system actually satisfies these equations. And satisfies these equations means satisfying the equations means that it makes them true, just like that Khan assignment where we had to plug in the values to see if it made them true. So will 2 comma 3 make this equation true? Let's try. 3 goes in for y, 1/2 times 2 plus 2. Let's see if this makes this equation true. It makes the left side equal to the right side. 1/2 of 2 is 1, right? I just simplified that. And now I add and I get 3 equals 3. Yes, it satisfies this equation. Satisfies, just like Snickers satisfies your hunger. Snickers satisfies this, Snickers. This coordinate pair satisfies this equal sign. All right, it makes the left side equal to the right side for this equation. Now let's try the other equation. For this to be a solution to the system, it has to satisfy both equations. All right, let's see if it does. -1 times 2 is -2 plus the 5. We get 3 equals, that would be 3 as well. So that is satisfied. The equal sign is satisfied because the left side is equal to the right side. So this, yay, it is our solution because it satisfies both equations. That's what it looks like with written out with the equations. This is what it looks like when we go back to the graph. On a graph, the solution is a point where they intersect, right? But when we do the work, it's the point that satisfies both equations, all right? That's important to understand. Just keep saying it to yourself, write it down in your notes, all right? Now we have to jump back to this and try a different problem. There's going to be tricky problems where, oh no, it's not in slope-intercept form. What do we do when something's not in slope-intercept form? Well, guess what? I gave you an idea down here. When an equation is not in slope-intercept form, you can graph it in several different methods, with several different methods. You can transform it into slope-intercept form. I think that's one of the hardest ones, and people make the most mistakes there. But this is a process that you were very good at. A lot of you were very good at finding the x and y intercepts, especially after you got a lot of practice. Go back to those notes and check it out and see if you remember. I'm going to do one example with you to help you out. Okay, so if we plot the x, find the x and y intercepts, then put them onto the graph for both of these equations, we can plot both of these lines and find the intersection point. All right, so let's do it. How do we do that here? All right, let's try it for that first equation. All right, remember, for the x-intercept, we plug in 0 for y, and for the y-intercept, you plug in 0 for x. All right, so we got x plus 0 equals -3. So then x plus 0 is just x equals -3. So my x-intercept is -3, 0. For the y-intercept, all right, we plug in 0 for x. So that's going to be 0 plus y equals 3. And that gives us y equals, -3, sorry, -3. And so that's going to be 0, -3. Now, we're going to go back and plot those, okay, on our graph. So get my blue out, and I got a -3, 0, and I got a 0, -3. All right, now I'm going to draw my line through those, and something that can help me is if I just kind of look between these and notice that, oh, look at that. It looks like it's perfectly going down a block, over a block, down a block, over a block. So I can help myself out and make it more accurate if I can throw in some extra dots there. And I can kind of follow this up here to the corner, yes, and strike my line. All right, and now I'm ready for my other problem, my other equation in this system, and I'm ready to find the y-intercepts. Okay, so if I go back here, remember, find my x-intercept by plugging in 0 for y. So 3x minus 3 times 0 equals 9. That part cancels out, so I just get 3x equals 9, divide by 3, divide by 3, x equals 3. And then for my y-intercept, I should write that as a coordinate pair just to help myself out. There you go, 3, 0. For my y-intercept, I got to plug in 0 for x. So there we have it. All right, I cancel that out. Careful, I got to bring down that minus sign. All right, because 0 minus 3y is -3y. And then divide by -3, divide by -3. y equals negative 3. Negative 3. And as a coordinate pair, that's going to be 0, comma, negative 3. Now, I'm going to go back to my graph here and plot that in a different color so I can see my different line. I've got 3, comma, 0. So that's over 3, down nothing. And then I have also, what is it? 0, negative 3, 0, negative 3. Ayo. Looks like I'm on to something here. I see that this line, again, follows that same pattern of kind of, oh, wow, that's cool. Goes up to the other corner. I didn't plan it like that, but it looks cool. All right. So when I plot this, I see that they intersect at a special point called the solution to the system of equations. That would be 0 over down 3. That'd be 0, comma, negative 3. 0, comma, negative 3 is what we call the solution to the system. If I plug it into both of these equations, it makes the equations true. It satisfies both of these equations. All right, our last example is an interesting situation. All right, when we graph both of these, you'll notice something funny. Luckily, they're both in slope-intercept form, so let's get cracking on plotting them. If they're in slope-intercept form, then just rock and roll. Plot the y-intercept of negative 3, and then the slope of up 1 over 2, up 1 over 2, up 1 over 2. All right, and then we can graph our line all the way through all of those. Boom. Okay, let's do the other one in red. And that's going to be at 1. All right, and then we're going to go up 1 over 2, up 1 over 2, up 1 over 2. It's interesting. It has like the same exact type of slope or slant or steepness. So when I draw this line in, it looks like they're parallel or they will never cross. Okay, so is there ever going to be a point that satisfies both of these equations? No, because the lines will never cross. Okay, so in here, when you type in your solution, when you do the activity today, you're going to put, instead of typing in the coordinate pair, you're going to write parallel. Oh, sorry, no, you're not going to write that. You're going to write no solution. All right, there's no point where they cross. All right, that's it for today. Hopefully you do pretty well, and just try, ask us, and we will be glad to help you. All right. Thanks so much for paying attention, and good luck.